Like any method in a .NET application, action methods usually need data to perform their work. And like other methods, the data can come from a variety of sources. They can come from the environment and state in which it's executing. The operating system can provide a lot of information. Or the nature of the user request, including the routing values from the parsed URL. You can also get information from direct parameters to the method passed from the browser as part of the request, and there's lots of other sources of information. What we're going to do now is talk about three broad sources of input for action methods, going from low-level to higher-level sources. We're going to talk about context objects, parameters, and finally model bindings. An action method will typically use just one of these sources, although it's certainly possible to mix and match them as you need in order for the method to do its work. The first source we'll talk about is a context object. Any kind of web request comes loaded with information. It includes the HTTP headers that structure the request, user information, browser and capability information, what the browser can do, the user's IP address, various kinds of authentication information, and so on. ASP.NET makes available a lot of that information as it receives it from IIS, and then MVC also adds its own information that you can take advantage of. So let's take a look at how this works. Here's a getContextInfo method within the Home controller. It uses a variety of context objects that are provided both by ASP.NET and MVC to get information about the environment user and the request that is coming in from the browser. In this case, it merely creates and returns a string to the browser that displays the results, but you could just as easily customize the action method's actions based on the conditions under which the code is processing the request. I'll go ahead and run the application. And I'll click on the context information, and here's the information that was produced by that method. Now obviously the results are going to depend upon your environment under which you run this code. The output isn't all that pretty, but it does show that simply by returning a string from the action method, you can get output in the browser window. And you can do far better. You can present this information within a view, or more often, as I mentioned, you'll customize what the action method does in order to present the user with different results. Notice that when I first ran this, the ID value was blank. I can change the URL manually by providing an ID parameter, and I'll just use randomly 15 and hit enter. And as you can see, I can also get information from the URL, the route that was defined when the user made this request. Now the code in this page uses only a few of the many context objects that are available, and only a few of their properties. For example, you can also use things like the request.queryString and request.form to extract specific query string and form field data, as well as request.cookies for your domain's cookie data stored on the user's machine. The HTTP context object has a rich supply of information about the application, including the cache as well as session information. It's great to have all that context information available through simple properties of built-in objects. But you can also receive specialized input customized for an action method through method parameters. The cool part about using parameters is how MVC takes care of populating their values for you. You actually have to do very little work, but you need to be aware of how the process works. When the action invoker executes an action method, the invoker examines several context objects and uses a model binder in order to attempt to assign values to the method's parameters. It searches things in a very specific order, looking for the first match that it finds. It first looks at the request.form object. This is a collection returned from a posted form, consisting of name-value pairs. This is the information that the user submitted from a regular HTML form on a web page. Next, it looks at the routeData.values collection. These are the values that the routing engine extracts from the requested URL. If you're using the default route defined in a new MVC project, this is going to consist of the controller name, action name, and maybe an ID value. but you can customize that route in an application to include more, less, or different information. And then finally it searches the query strings that are passed as part of the URL. And these also consist of name-value pairs. Now the model binder matches parameters solely by name. It's the name of the object in the various collections it searches and the name of the parameter. Once it finds a match for the parameter, it doesn't search any further for more matches. All of this means that in order to take advantage of this automated mechanism for populating parameters, you're going to have to carefully coordinate parameter names with the names of the values in the various collections. If you do have duplicate names, such as an ID form field name, the default route ID value, and an ID query string if you have one, you'll have to write code in the action method to extract those specific values from, say, the request.queryString collection or the routeData.values collection. This is because the action invoker is going to stop when it finds the ID value that was passed as part of the form. Now it's important to understand that the model binder maps request values to .NET types. It can create types at various levels, not just simple data types. It can populate an entire model class consisting of many properties in the same way it maps action method parameters. It can also create a form collection object that contains all of the values of the posted form. So you have a lot of options in how you retrieve these parameters. Here's a useParameters action method that takes 4 parameters: an ID, name, controller, and action. Now notice that the code does nothing to populate the values of these parameters. It just directly uses them by concatenating together a string that will be presented to the user. That's the return value to the user. MVC is taking care of attempting to read these values from those various collections in the order that I talked about. I'll go ahead and run the application and click on the Use Parameters link there. And there's the results. Here's the URL. It's just specifying the controller name and the action method name. And so those are picked up by that action method. But because I didn't specify an ID value, and there's no name value that's in any of the collections that MVC searches, those fields are blank. So what I'll do now is I'll go ahead and manually change this URL by providing an ID value as well as a name query string value. I'll hit enter, and notice that those parameters now are populated with those values. The same thing would have happened here if, for example, I had a form, if this page was actually a form, and I had a name form field within the page. Now what would happen if the action invoker can't find a match for a parameter in any of the collections that it searches? Well, in that case, it attempts to assign a null or nothing to the parameter. This is fine for reference and nullable data types, but not so good for other parameter types for which you'll get an exception. The nice thing is that most of the time you'll be working with strings. And a string is a reference value, so in most cases you're probably going to be okay with the null or a nothing. Another way that you can populate the value of an action method parameter is through a model binding. A model encapsulates the data and business rules of an MVC application, and you can use a model directly with your controllers and views. Because this is such a common requirement, ASP.NET MVC has many built-in features that make using model objects very easy. For example, it uses reflection and other features of the .NET framework to automatically create data scaffolding to let the user interact with the data in the model and process the model within the controller. Data scaffolding is basically just automatically generating the core parts of a page, so you don't have to build it all by hand based on a particular data model. So let's take a look at how this works. The sample application uses a very simple dog model to hold some basic information about our sled dogs. I'll go ahead and open that up. As you can see, it uses automatic properties to define an ID value of type int, a name property of type string, and an age property of type int. And the class is within the controllers.models namespace of the sample application. Obviously, this is a very simplified model, but it'll suit our needs here. Now I'll open up the dog controller. This is a reasonably full-featured controller for creating, editing, listing, and viewing the details of dog records. Here I'm only going to focus on the edit action method that works with dog objects to let the user edit an existing record. The dog controller class inherits from the MVC controller class and includes a private dogs field that contains a generic list of dogs that the user has entered. So this is an in-memory storage of the dog information. Now I'll go down to the edit action methods. As you can see, there are two of them. One handles an HTTP GET, which displays a form with the data for an existing dog object. This is the view that the user gets in order to edit the information. The format of the URL is something like dog/edit/5, where 5 is the ID value for the dog. This indicates that the user wants to edit the dog with that ID value. The action invoker is going to pass that value in as the ID parameter, which the code then uses to grab the desired dog. So it news up a dog object and then loops through all of the dogs within that dogs field. That's that collection of existing dogs that's defined as a class level field. Once it finds a match, then it populates the different parameter values of that new dog object here and uses that as the model to which the view is bound. So in essence, this return statement is instantiating and displaying a view to the user and binding it to that dog object. Then MVC takes care of the magic that binds the dog object to the view. So let's take a look at that edit view. Here you can see that it inherits from system.web.mvc.view page, and it's bound to that controllers.model.dog object. So this is now the source of the strongly typed view for this page. The important thing here is to understand that MVC takes care of all of the work of binding the dog object to the elements in the view, as well as posting them back to the HTTP post version of the edit action method. So as you can see, throughout the form, which was auto-generated by MVC, it uses that model object. This is reading the model property of that view page object, which is bound to that dog object. And so you can read the different field values of that dog ID. And when I hover over it, you can see that it's strongly bound to that dog object. In fact, when you're typing this code out within this page, you'll get full IntelliSense on that model object, and it'll display the different properties for the dog object. So this is how the form is presented to the user, reading the values of the existing dog object. When the user posts the page back, the second edit action method kicks into action. It receives an object of type dog. Here's where the model binder is doing its work. When MVC sees that it's receiving a parameter of type dog, it's going to look at the properties of that dog object and read the different property values that are being passed through the various collections, the forms collection, the query string collection, and the route values. It then matches up those properties because it finds matches on names, and then the result is that this D object is a fully populated dog object that contains all of the updated values that the user typed into that form, if there are any. Then what the code does is it checks to make sure that the model state is valid. It checks to make sure that all of the values that the user entered are okay. You can use data validation. It also makes sure that if a parameter type is an integer, that it is in fact a valid integer value. If it's not valid, then it's going to return that same edit view and pass in that dog object. So this is the dog object with the changes that the user made. And so they'll be able to see all their changes, except possibly some invalid data type values. But otherwise, if the user entered valid data, it's going to once again loop through all of the objects in that dogs collection within this controller. When it finds a match, it's then going to update the information within that collection. Now this is relatively inefficient, but with this in-memory dog collection, there aren't going to be all that many objects. But you can also use LINQ in order to go directly to a particular object that has the ID value. And notice that I'm not updating the ID value because we know that those match. That's essentially the primary key on that object. So when it finds that object, it updates the dog object and then redirects to the index view. You could redirect to any page that you wanted to. It's important to understand that this is just one simple example of how model binding can work in an ASP.NET MVC application. In many cases, you can write even less code than is contained within this sample application, depending on the model and how you're using it. Of course, you can also write a lot more code if you want to handle complex situations.